Physics in the Flesh is back with another circular motion problem. Centripetal acceleration of space shuttle in orbit. Suppose the space shuttle is in orbit 410 kilometers from Earth's surface and circles the Earth about once every 92 minutes. Find the centripetal acceleration of the space shuttle in its orbit. Express your answer in terms of g, the gravitational acceleration at the Earth's surface. Okay, so let's get started. First things first, let's draw a picture. So here's the Earth. Okay, so we're going to have a space shuttle in orbit around it. So I'm going to draw out the orbit first. So there's that. And this is going to be my space shuttle. Okay, very artistic. Now let's label this diagram. We know, and we're given, the distance from Earth's surface. So be careful when you label this in your picture. Okay, so the 410, that's this distance right here. Okay, so 410. Please note this diagram is not to scale. It's far from it. But if I were to draw it to scale, it would be very difficult to read it. Okay, so here we go. 410 kilometers is that distance. We are looking for the centripetal acceleration. And we know that when we're looking for centripetal acceleration, we need the distance from the object that's undergoing the acceleration to the center of rotation. And the center of rotation is at the center of the Earth. Okay, so in addition to this distance, we need the radius of the Earth. Okay, so we're going to need that as well. We're going to call 410 the distance from the shuttle to the Earth. Okay, so RSE, okay, that came out a little bit messy there. Really need to get thinner markers. Okay, so RSE is equal to 410 kilometers. And as with many things in science and physics, especially, we have to convert that to meters. So we're going to multiply that by 1,000, and expressing it that in scientific notation, we're going to get 4.10 times 10 to the 5 meters. Next, we're told that every 92 minutes, the shuttle goes around once. That's called the period of the orbit. Okay, and period is a form of time. The only difference is we don't label it as a lowercase t like we would regular time. Because it's period, it gets the letter capital T. Okay, so capital T period is 92 minutes. Okay, so to get that in seconds, well, we know that 60 seconds is 1 minute. So you're multiplying this expression by 1. The minutes cancel. 92 times 60 is 5520 seconds. So we've got our period. We've got the distance from this space shuttle to the Earth. And now we want to find this total radius. We'll call that RT because that's the one we're going to use in our calculation. Okay, so let's do that over here. RT is equal to RSE plus RE. Now in this question, they don't tell you the radius of the Earth. Those types of things, mass of the Earth, radius of the Earth, acceleration due to gravity at Earth's surface, those are numbers that are not given to you in a problem. It's expected that you will either look it up on a formula sheet or you will just have it memorized. Okay, so let's plug in our RSE. It's 4.10 times 10 to the 5 meters. Okay, radius of the Earth is 6.38 times 10 to the 6 meters. Notice that is an entire factor of 10 bigger than that. Okay, that's why I said this is definitely not the scale. But, you know, for the purposes of this problem, it's fine. Okay, adding the two of those together, you get 6.79 times 10 to the 6 meters. And this is the distance we're going to use in our formula. Okay, next. The question is asking us to find the centripetal acceleration. That's this. AC equals v squared over r. Okay, so the only thing we're missing from this equation is the v, right? Let's find the speed. Okay, think about the problem logically. This space shuttle is covering this much distance. It's traveling a circular distance within this many seconds. Okay, so speed, if you want to find speed, speed is just distance over time. It's as simple as that. And the time is the period for it to go around once. The distance is, well, how far do you travel if you trace out a circle? Okay, that means you're following the circumference of a circle. So the distance you travel is the circumference of a circle that has radius RT, okay, or this. And the time is capital T for the period. So if you plug that in, 2 pi r, okay, so Actually, let's do this a bit more to the left here. I'm going to run out of space. 2 pi r is 6.79 times 10 to the 6 meters divided by t, 5520 seconds. Okay, when you calculate that out, you are going to get v equals 7.73 times 10 to the 3 meters per second. So there's your speed. You can plug that in over here. Okay, so now AC is v squared over r. So we do 7.73 times 10 to the 3 meters per second squared divided by r, that's RT. 6.79 times 10 to the 6. Okay, you could have just as easily used this formula, plugged it in here and simplified it a bit. Okay, both ways work. Okay, if you plug that in and you solve, you are going to get the centripetal acceleration is 8.8 meters per second squared. Okay, so there's the acceleration. We're almost done. We need to express the answer in terms of g. Okay, so if you checked out video 74, we actually did the same thing. Okay, so what you need to do to express it in terms of g is simply take your value, 8.8 meters per second squared, and you multiply by 1. And you tell yourself that 1g is 9.8 meters per second squared. So what happens is the meters per second squared cancel, divide those two numbers, and you are going to get 0.898 G's. Now we need to round this to 2 sig figs because that has 2 sig figs, 2 sig figs. Okay, so we're going to round that to 0.90 G's. Okay, so that's it for this video, guys. I hope you enjoyed it. If you did, be sure to click that like button and subscribe to Physics in the Flesh as I post new videos every weekday at 12 noon. Enjoy the rest of your day, guys.